Obtain condition for parallel resonance. Obtain condition for parallel resonance. When inductor L and capacitor C are connected in parallel across alternating source of EMF E0 sin omega t, then circuit is called as parallel resonance circuit. Let I be the instantaneous current. At point A, current I gets divided into two parts, IL and IC. See again. Huh? When an inductor L, comma, capacitor C are connected in parallel across alternating source of EMF equals to E0 sin omega t, then circuit is called as parallel resonance circuit. Let I be the instantaneous current. Okay, please copy this much first. Draw the diagram and write this much. Current.
Yes.
समझा किसको बोलते हैं पैरेलल रेजोनेंस सर्किट?
हाँ सर.
ठीक है, इतना लिख लो डायग्राम बना के. Kame, you could not attend that doctor's batch.
So I thought 12:30, so I didn't realize 6 पे था and I checked बहुत late.
देखो आपको बताता हूँ लेक्चर कब होता है.
हाँ.
मंडे 12:30, ट्यूसडे नो लेक्चर, वेडनेसडे थर्सडे सैटरडे 12:30, खाली फ्राइडे 6 to 7 होता है.
Okay sir. I was not aware. Sorry.
क्योंकि वो बैठोगे तो आपको बहुत फायदा होगा. मैं बार बार बोल रहा हूँ. मतलब देयर विल बी ड्रास्टिक चेंज इन योर मार्क्स.
Okay sir.
मतलब आर यू कंफर्टेबल विद दैट टाइमिंग?
हाँ sir, I'm comfortable with the time.
ठीक है.
Done, sir.
Okay. So I wrote let I be the instantaneous current. After this, please stop. Just understand me. Let I be the instantaneous current at point A. Current gets divided into two parts, IL comma IC, flowing through inductor and capacitor respectively. Now, in AC circuit with inductor, current is leading or lagging the EMF? In inductor, current lags or lead? Yes, Kamya?
Lags, I guess.
Correct.
In
EMF lead, current lags by 90 degree. And in capacitor, current leads by 90 degree. Correct? So imagine one is lagging by 90, other is leading by 90. So what is difference of angle between them? Hence, what is phase difference between them? Yes, what is phase difference between them?
180
zero.
degrees.
180 degree. So it is like two vectors are at 180 degree. Therefore, what is resultant then? Resultant current I, can I say it will be IL difference with IC? Hello?
Yeah, sir.
See, generally, if it is pure resistance, then current I gets divided into I1, I2. We say I is I1 plus I2. But in AC circuit with inductor, we will say IL difference with IC. Because in one circuit it is lagging, other circuit it is leading. So one is lagging by 90, other is leading by 90. Net path phase difference is 180 degree. Okay. So result will be difference. Please write this much again.
Done, sir.
तो मेरा फैन जो होगा ना उसके अंदर उसने लिक्विड दिया उसके आने के बाद I is IL, difference with IC. So it is voltage upon its resistance, inductor. Voltage upon resistance of capacitor. So I is E into 1 upon XL, difference with 1 upon XC. When XL equal to XC, I becomes E into 0, therefore I is 0. This is condition for parallel resonance. उसका शॉप का नाम क्या है?
Done, sir.
So in series resonance, we got current maximum. In parallel resonance, we are getting 0. Now define resonant frequency and derive its expression. Define resonant frequency and derive its expression. The frequency at which inductive reactance is same as capacitive reactance. The frequency at which inductive reactance is same as capacitive reactance is called as resonant frequency. Now let F R be the resonant frequency. Since at resonance XL, that means inductive reactance is same as capacitive reactance. XL equal to XC. So omega L is 1 upon omega C. Omega square 1 by LC. Omega 1 upon root LC. 2 pi FR is 1 upon root LC. So resonant frequency is 1 upon 2 pi root LC. Oh, right, this much. Completed full?
Yes, sir, completed.
What time you have to read current?
By around 9:45.
9:45. So why you are so much worried, man?
I am not worried.
No, our lecture is till 9 o'clock only. So 9:45 you have to go.
I
8:45 I think.
8:45.
मतलब सच बात आप
8:45.
नहीं नहीं सच बोल दिया आपने
8:45.
9:45 ओके
अरे नहीं 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 सर, 9 बजे तो पहुंचना है.
अभी तो गलती से 9:45 बोल दिया सच्ची टाइम
हाँ वही, मैंने गलती से 9:45 बोल
नहीं
दिया.
मतलब
8:45.
गलती से सही टाइम बोल दिया
अरे नहीं सर.
आपने चलो 8:45 निकल जाना आप हाँ
ओके.
अदर सब रिटर्न फुल
Yes, sir.
Yes, sir.
ओके ग्राफ ऑफ I means current versus frequency for series resonance. So frequency which we can change is on x-axis, current which we will get is along y-axis. What is general formula for current by Ohm's law, Kamya?
V is IR वाला. So is V by R.
I is V by R, correct. Here R means impedance, na? In AC circuit, total resistance is called impedance, no?
Yes, sir.
And impedance is root of R square plus XL minus XC square, okay?
हाँ sir.
That means if this factor goes on decreasing, so denominator will go on decreasing because R is fixed, it does not depend upon frequency that day I had written for you. Hello?
Yes, sir.
So if this XL minus XC goes on decreasing, so can I say denominator will go on decreasing? नहीं समझ रहा है. Hello?
हाँ sir. नहीं हाँ sir.
तो अगर डिनोमिनेटर कम हो गया तो आंसर ज्यादा होगा ना.
हाँ.
तो जरा चेक करते हैं क्या
हाँ,
होने वाला है. हाँ तो एट लोअर फ्रीक्वेंसी XC is greater than XL. सपोज ये लोअर फ्रीक्वेंसी पे 100 है, ये 0 है, तो डिफरेंस 100 होगा क्या? नहीं, करेक्ट.
हाँ.
Now I'm increasing the frequency. So XC will start decreasing 90, 80, 70, 60, 50, 40, 30, 20, 10, finally 0. And XL will start increasing 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now what about difference? What is 90 minus 10? 80.
80.
So denominator has decreased ना, पहले 100 था, अभी 80 हो गया ना.
Yes.
So current will increase. Now difference becomes 70 minus 30 is 40, then 20, then 0, back to 20. So what I can see, denominator is decreasing, answer will increase, 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 again decrease, 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 decrease. Got it?
हाँ sir.
नहीं समझा तो बोलो फिर से. हेलो, नहीं समझा ये?
समझा सर.
Okay.
समझा सर.
So from minimum it will start increase, 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 become maximum. This maximum current happens when in resonance or not for series circuit, and I maximum formula is E by Z equals to only E by R. Again decreases. I hope you followed. Yes, clear?
Yes, sir.
Do it now.
Done, sir.
Now, parallel resonance. For parallel resonance, graph of I versus frequency. In this case, what should current become at resonance? Zero, no, ideally. Hello?
Yeah, sir.
Now, what is current? E into 1 upon XL, difference with 1 upon XC we got in parallel resonance, if you recollect. At lower frequency, XL is small, so its reciprocal will be large. And this will be small, I'm assuming 0. So it will, I will be E into 100. But as frequency increases, this will become larger and this will become smaller and this will become larger. What is difference now? 80. So it will become E into 80. Current is decreasing or increasing?
Decreasing.
And when it becomes equal, then it will become 0. So from maximum, it will start decreasing, becomes 0, but practically it will not become 0. And then again increases. So this is I minimum and frequency is resonant frequency. This is practical graph and ideally it is 0. This is ideal. Draw this graph now. So this wala graph is for series resonance. This is for parallel resonance.
Done, sir.
Okay. This one done. So till this you have in the syllabus, rest all part is deleted for you this time. So just for note, write down Q factor or quality factor, just for a note, is ratio of the ratio of angular frequency at resonance to the resistance is called as Q factor. That is Q equals to omega naught. In fact, it is omega naught ratio of inductive reactance at resonance to the resistance. So inductive reactance XL upon R at resonance, it is omega naught into L by R. 1 upon root of LC is omega. See, XL is same as XC. So omega L is 1 upon omega C. Omega square 1 by LC. So at resonance, omega is 1 upon root LC into L by R. If you bring L in root, then can I say it is L square in root upon LC into 1 by R. 1 L gets cancelled. So 1 upon R root of L by C is quality factor. Just write for your information. Actually, they have not included now in the syllabus. So those who are not trying for entrance, they need not prepare. So I've completed full EMI today without numerical. As I said, first I'm doing theory, then in revision I will do all numericals so that you retain in your mind. Just complete this, then I will start with new chapter, semiconductor today for you.
So can I leave?
Yes, yes, yes.
Okay, so bye.
Done, sir.
Done, sir.
फिर आज ही स्टॉप कर देते हैं इधर बिकॉज नया चैप्टर स्टार्ट करना है.